Welcome and hello. This is a video exercise in HEC RAS. And in this exercise, we're going to be dealing with gridded global boundary condition data, specifically precipitation data that we add as a boundary condition to our 2D RAS model. All right, what I have on the screen here is the 2D user's manual, which is titled Global Boundary Conditions. And I've actually already covered the contents of this webpage in lesson 83. But the reason I'm bringing this up is because when I went to add in gridded precipitation data right here, there was just too much to talk about in that lesson. So what I'm doing in this video, this exercise, is to describe how to actually get that precipitation data in the gridded format and then import that into your HEC HMS. It's going to be imported into HEC RAS mapper, and then we will ultimately be able to see precipitation data on our HEC RAS mapper interface, similar to what you're seeing here in the user's manual. All right, so let's go ahead and get started. What I have on the screen here is my HEC RAS. I'm going to go File, New Project, and then navigate to where I want to save that project. Go ahead and give your project the title. It's Exercise 31, and then click OK. All right, and then here is my RAS mapper up on the screen here. I'm going to start by creating a geometry, so we'll just call that base. And then I next want to add a terrain. So to do that, I will go ahead and download USGS files. It's telling me it wants a spatial reference system, so I should probably do that as well. So I'm going to click no. Okay, so let me just go back to project, set projection. I can also get to this dialog box here by going up to Tools, Options, and then this first menu here is the projection. It's looking for a projection file or a well-known text, so let's go ahead and grab that first. So wherever your project location is, you're going to want to have a projection file that is appropriate for that location. This brings us to the next page. I'm going to add a bunch of links to the description of this video. Spatialreference.com. I'm going to click on EPSG as the projection type, and then I'm going to be working in Northern Colorado. So I'll click on Colorado, and then Northern Colorado, I'm going to download this one right here, 26953, and we have some well-known texts, a map. I'm just going to click on this .prj file, and it will download that projection file here to the browser's default download location. I'm going to move that projection file here into my project directory. So it's just 26953. In fact, I'm going to go ahead and rename that, just say projection. So I know .prj as the file extension is not a project like what we're seeing up here. Okay. So there's that. I'm going to go ahead and minimize this. Go back to my RAS mapper. Oops. Here we go. And then navigate to that projection file that I just saved. Okay. So here it is. Easy enough. Apply and OK. Next, what we want to do is download the USGS terrain data. That's how I'm going to proceed with this exercise. And then after that, we'll eventually get that precipitation data. But I want to get the terrain data up on the map first because that is the natural order of things to load into your RAS mapper. We can go right click, download terrain data, USGS. Another way to get to this dialog box is to go up to Project, Download Data, USGS Terrain. Okay, this time it's not bothering me with the projection because I already have that in place. And then for the source extents, current view really doesn't work for me because if you think about it, I don't know where in the world I am. I don't have any maps already loaded or any reference points. So our other options are geometry, shapefile, and latitude, longitude. Let's go ahead and give latitude, longitude a try for this exercise. I mean, any of these options would work, if we really wanted to make it work. But let's go lat long. Now I need to specify the top left and bottom right coordinates in latitude, longitude. All right, so let's go ahead and select a location in Northern Colorado. So here's Denver. I'm going to go ahead and check out that South Platte River. So how about right here? I just arbitrarily chose this place. It needed to be somewhere along a river in Northern Colorado. All right, so there's a lot of mapping systems like this for free. Google Earth is the one I like to use. On the bottom of the screen, you see a latitude north and then a longitude west. So that would be positive 40 degrees and so on, negative 104 and so on, because west is the negative longitude value. I'm going to go ahead and just put my cursor over the river and then take that single point as my top left corner and my bottom right corner. So it's really just a point that I'm going to be asking HEC RAS mapper to give me the USGS files for. All right, so on the bottom of the screen, it says 40, 19, 18. So I'll just do a 18 divided by 60, add that to 19, divide that by 60, and that is 0.3216. And then the longitude, this is net west, so let's go with 4.81 divided by 60, add that to 23, divide that by 60. I'm just converting degree minute second to decimal degree. Nothing too fancy here. So our longitude is going to be negative 104.3847. Let's go ahead and minimize Google Earth. And now click on this button to specify the lat long of our top left and bottom right points. All right, so here's the interface. I'll type in the latitude of 40.3217, tab negative 104.3847, and OK. Now for the bottom left or the bottom right, I'll just type in the same thing. You may want to actually include an area, but I'm just not going to do that here. Negative 104.3847. All right, I'm going to go ahead and click OK. I want to download elevation models, so I'll click on Query Products. It'll bring up all the data. So it looks like there's two 1 meter files and then a bunch of 10 meter files and then some 30 meter files. I'm going to click on the checkbox to download the two 1 meter cell size files and then click on download right here. Where it's going to download is my terrain data in USGS. So let's wait for that. All right, while that's downloading, I'm going to come over here to PRISM data. There's lots of information and sources online for precipitation data. PRISM's been one of my go-to sources for matching correct volume, at least, but it has continental United States precipitation data on a daily time step. So let's go ahead and use that. I'm going to click on, let's see, recent years, and then I'll leave a link to this PRISM website in the description of the video as well. But yeah, click on recent years. And then what I want to do is click on daily data. And then I'm going to choose the year. This is going to be for 2021, October. And then I'm going to choose all days of October. So I'm not going to specify a certain day. And then click download all data. Okay, so it looks like the download was complete. So let's just say okay and get back to that in a moment. Okay, so here are the files. Thank you. And then I'm going to click on download all data for the month. So this is going to be a 31 separate bill files, I believe. I'll go ahead and click that to download the precipitation data. All right, so that's been downloaded. I'm going to go ahead and unzip that or extract it just onto my desktop. Click extract. Okay, so that's extracted. I'm going to delete the original zip file that downloaded and then open up this folder here. Okay, so I think these are bill files. Yep. And this is the standard PRISM format. So PPT here represents the precipitation data. We're looking good. All right, so I'm going to go ahead and close that. And then we have a few things to do here. Let me go back to RAS Mapper. We've downloaded those files. Let's go ahead and load those files in and then get back to the precipitation task. So close. And then now we can finally right click, create new RAS terrain. So this up here is to download the files. This right here, create a new RAS terrain, is to actually load those downloaded files into your RAS mapper. All right, so now I can navigate to that terrain data. So here's my project, terrain, USGS. Here are the two TIFF files. And then, I'm just kind of curious what the size was, details. So they're both about 300 megabytes, 400 megabytes. All right. So open both of those up, and then I believe I need to convert, and we're good to go. So I'm going to go ahead and click create. This routine is going to take a couple minutes, so let's get back to the precipitation data. All right, here's the project directory, and then here is the precipitation files that I downloaded from that PRISM website. What I need to do is use the importer tool to convert these bill files to a DSS view file or paths within the DSS file. So what I'm going to do here, this is still loading in here. I'm going to go to HEC RAS, go to edit, and then unsteady flow data. Here's the meteorological data tab where we're going to be putting in our precipitation. So I'm going to enable precipitation. And then for precipitation, the mode is going to be gridded. Now I need to specify either DSS data or raster files. I've always had better experience and thought it was easier to work with DSS data, especially with the importer tool that's part of the HEC Vortex suite of utility tools, which is also integrated into HEC HMS. So basically, we've got those PRISM files downloaded. But what we need to do is only import the PRISM files to our specific projection and also to our area of interest, which is that northern Colorado South Platte River region. And to do that, we need to create a shape file to mask out all the other areas within the continental United States we don't need precipitation data for. So we're going to go ahead and create a shape file to use as a mask for the importer tool, and we already have the projection file. I heard the fan on my computer slow down, which leads me to believe that RAS Mapper is done. Oh, it's not? Okay, it just finished up. I'll click close. Here is our river. It's flowing in the southeast direction. And then if I back out, yeah, okay, so here's the total extents of that USGS terrain data that I downloaded. This looks good. In fact, I can use these same maps to assist me in creating a shapefile that I'll use to mask when importing that precipitation data. So let's go ahead and fire up QGIS. I have that right here. QGIS is an open source GIS software. It's great. Definitely recommend it for random GIS utility tasks like what I'm about to do right here. All right, let's go ahead and first of all file and create file properties. I'm going to set the projection. So CRS is coordinate reference system. And in preparation for this lesson, I've already loaded up my EPSG 26953. So this is the coordinate system I'm going to use. But if you have a coordinate system, you can just type in like 29653 up here, or what was it, 26953, and then that would show up in the filter, 26953. Okay, so you just go ahead and click that one right there, and then down at the bottom, click apply, and okay. Before I forget, I'm going to go ahead and save this project. So file, save. I'm going to put this in my project directory, which is right here. QGIS project, and then click on save. Okay, so that's done. Next, I want to load in those two USGS TIFF files, the elevation data. So you can go up to layer, add layer, and then add raster layer, because these are TIFF files, elevation data, and then raster is already selected. You can get to the same dialog box by just clicking on this button, I believe, because that is in the layers panel. Okay, and then raster, so same location. Now I'm going to navigate to those two TIFF files, RAS exercises 31 project terrain, sorry, USGS. Here are those two TIFF files right there. Okay. So I'm going to click open, add. All right. So here are the two panels. It looks like this lower one's the only important one. And then now what I want to do is create a polygon shape file to use as a mask for that precipitation data import task. What I'm going to do is zoom out a good ways. So this is the area I'm interested in, but I want more area for the precipitation. So I'm going to go ahead and just sketch an area right here. Let's go up to layer and now create layer. This is going to be new shape file. For the name, I'm going to call this precip data mask. And then UTF-8 coding, the geometry type is going to be polygon. And then I want to set the projection here to that same northern Colorado right here, 26953. And I think everything else is good. So I'll click OK. Now over here in the layers panel, I've got my polygon shape file. I want to start editing it. So I'm going to click on the edit pencil and then the start edit button. Now I'm just going to do a single left click, single left click, single left click, single left click. That's a good area. And then I'm going to do a right click. That's going to stop the editing. I'll just give it an ID of 1 is fine. And then OK. All right, so that is saved and ready to go. I could go right click and export file. And actually that is required. I need to actually save this shape file in my project directory. So let's go ahead and navigate to the project, 31 project. Now what I'm going to do is actually create a separate directory here for GIS data. Actually, okay. I don't think I can create a directory at the moment. I'll just put all the shape files in here right now. So I'm going to call this, again, precip data mask, and then click save. So that probably saved. I want to put that in a separate directory, like a GIS or shapefiles directory. Oh, actually, it doesn't save until I click OK right here. Okay, now it's saved. So I'm going to go ahead and save the QGIS project, minimize that. Let's go up to the project directory. And now we have all these files that I really don't want here. So I'm going to go right click, new directory. I'm going to call this GIS and then move all of these precip data mask files into that GIS directory. So just move them right there. Okay. It looks like it wants me to close the QGIS before it'll move all the files over, so that's fine. I'll just go ahead and save, and then retry. All right, and while I'm at it, I'll move my QGZ file over as well. So that shapefile is going to be used as my mask when using the importer tool. Let's go ahead and tackle that importer tool now and create the gridded data sets from the PRISM data so that they become precipitation gridded sets in the DSS format, which we can read into our unsteady flow data right here. Okay, so to do that, let's go ahead and go to HEC Vortex. This is an article that explains the HEC Vortex tools. Very helpful, very insightful. Towards the middle, it talks about the different tools. And the first, and I would say the best one, is this importer tool. It takes data like gridded data, source data, such as netcdf, grib, hdf, ASCII, BIL, and it converts it to the HEC DSS format. So what we have is precipitation data, but it could be pressure data, it could be wind speed, it could be evapotranspiration, any gridded data set, snow. So if you're used to HMS, you've probably done this routine a few times before. There is a importer tool within HEC Vortex standalone, and it's also been integrated into HEC HMS. So if you open up HEC HMS, I'll show you where that is. And there's no reason we couldn't use it in HEC HMS either. You'd go up to File, Import, Gridded Data Importer, and then boom, here it is. This is the first step of the Gridded Data Importer wizard. So you don't have to necessarily be using HEC HMS to utilize the importer tool that's integrated into this program. All right, if you want to use the standalone, that's not a problem. There is a page here. I'll leave this link in the description, but you can download it from the HEC GitHub page. The current version at the time of this recording is 0.11.18. Here is the main Vortex page. You can go ahead and just download the zip that way, unzip the files. I was having trouble with this on my machine, so I went ahead and looked and downloaded the 0.16 version. I just went to the previous release and then downloaded this one right here, version 0.11.16, expand the different downloads, and then downloaded this file right here. I'm not going to do that in this exercise because it's already done. Here it is. I opened up Vortex 0.11.16, went to the bin, and now here are the individual tools that run as executables directly. So I'm going to come down here to Importer, click on Import Tool. Now, if it doesn't open up for you right away on a Windows machine, then it may tell you to not run or give you a link to click on that says More Info. Click on the More Info link and then click on the Run option. And then it should come up like this. If not, just download HMS and use the importer tool that's built into HMS. All right, here's the first step, add files. What it's looking for is the source files. In this case, our .bil files we downloaded from the PRISM website. So I'm going to click on the open folder icon here. I'm going to navigate to the project directory and then click on PRISM. These are my bil files. All right, so here are my 31 days of data. I'm just going to go ahead and select one and then click Control A to select them all. Then click Open. All right, I have 31 days of precipitation data already loaded here. This is the entire continental United States, I believe. And then click Next. Our only variable to select is the one we want. PPT is the code for precipitation. So just double click that, or you can click it and then arrow right and then click Next. This is the dialog page that allows us to specify the shapefile and then the projection. So we need to do both. I'll navigate to that shapefile we're using as a mask by clicking on this button. Here is the project directory. Here is the GIS folder. And then here is that shapefile that we created in QGIS and then open. All right, the well-known text, this is the projection. So I'll go ahead and navigate to our projection file. Here's the project directory. Here is our projection. So I'll click open. Now, whatever the original cell size is, I'm going to just assume that that's fine. So I'm not going to specify cell size, but if I wanted to, I could type in a number right there. And then resampling method, I'll just leave it at bilinear and click next. All right, now it's asking for where I want the resulting DSS file to be saved to. So let's go ahead and open up our project once again. Here's the project directory. I'm just going to save it directly into that project directory. So I'll just call it precip data and then open. Okay. And then these are the path name parts of that DSS file. Part C is going to be reserved for precipitation, and then parts D and E is the start and end date time, I believe. I'm only going to have one DSS file and then one series of paths. So I'm going to leave these blank and then go ahead and click next. All right, so it went ahead and did its thing. I think that was successful. You can close or restart. If you restart, it's just going to send you back to step one. But I think I'm done with this for now. I'll just go ahead and minimize it. Let's go ahead and check out our project files. All right, so precip data.dss, it's right here. It's kind of a small file, 325 kilobytes. So let's go ahead and load that up into our RAS mapper and then go ahead and see what it looks like. I'm going to go ahead and check it out in DSS view first, just because that's simple to use and that's specifically developed for DSS files. Let's go ahead and file, open, go to the project directory, click on precip data.dss, and that is a good sign. Okay, let me go ahead and just double click and then select all and view the data. Okay, so it looks like we do have some precipitation. This coloration here shows that there's precipitation on the first day, second day, third day, and so on. Okay, let's go ahead and bring this data into our HEC RAS now. So let's minimize that back to HEC RAS, specifically the unsteady flow data. For file name, I'm going to go ahead and click to open up and navigate to our project directory. Here is the precip data.dss, and then here are the individual daily precipitation grid data for that month of October 2021. So I'm going to select the first file and then click OK. And that is all we have to do here. Oh, except for the interpolation method. I'll just go ahead and say bilinear once again, and then file and save unsteady flow data. For the title, I'm going to call this base and then click OK. And I think that's good. I'll go ahead and close this. Let's go ahead and return to RAS Mapper now and see what our results look like. Over in event conditions, I'm expecting to see our precipitation data, and I don't see it yet. Let me close some of this background action. Let me go ahead and close RAS Mapper as well, and then just open it up again, and hopefully we'll see that precipitation data. Okay, so now I have a plus symbol beside event conditions. And if I toggle on the base data and then click on precipitation and precipitation accumulative, or that's cumulative values, I should be seeing this on the map, but I'm just guessing that there's no precipitation in this particular view. Because remember, the polygon shapefile we used to crop was much larger than the actual terrain right here. And I did that for a reason in the event that we didn't have any precipitation at this location for the month of data that we downloaded. So I'm going to zoom out a little bit further and hopefully see some precipitation data show up on the map. And here it is kind of over to the side. Okay, we can kind of get a sense of the extent of the map the more I zoom out. Now I'm going to pan a little bit. What we're seeing is just the first day. It looks like there's a little bit of precipitation in the southwest corner of the area that I cropped out. Again, this is northern Colorado. I'm going to go ahead and click on precipitation in the menu. And then I have my range of precipitation values from 0 to 1 inch. And also, if I click on the cumulative precipitation layer, I have values ranging from 0 up to 15 inches. Now, this right here is just the first day of the month, but I can use the controls up here to toggle through different days. So let me make this a little bit wider. Okay, so we have like a play bar here. The cumulative precipitation, let me go ahead and click on this label here. Okay, so we're back to October 1st, it looks like. Okay, so here are the different days of data. This is the precipitation, October 10th, 11th, 12th, 13th, 14th, 15th, and so on. You can also play this through with an animation just by clicking on this green play button. So let's see what happens. Okay, so that was the entire month in about 1 second, but I can slow down the controls if I click on this turtle button and then move the slider closer to the turtle. So 28 seconds. How about 15 seconds? Okay, then let's play that back. So play. So this is a little bit slower. Again, once per day is probably not very good. One layer per day isn't quite as precise as you might be used to seeing on the Weather Channel, where you get a new frame every 15 seconds or 1 hour. But our precipitation data is in place. It looks like it doesn't actually rain or provide any precipitation along the river, at least not for this month, and that's fine too. The exercise was just demonstrate how to load in precipitation into your HEC RAS model. If we zoom in on a location that does have precipitation though, and we have this precipitation layer selected, then wherever I move my mouse, you can see we have the actual values of precipitation. Now keep in mind, this is the daily precipitation. If I wanted to see the accumulative precipitation for the entire month, I could just go right click, plot accumulative precipitation, and now we have the increase of precipitation at that particular location over the course of October 2021, and it goes from 0 up to just over 3 inches. Okay. If you wanted the incremental precipitation, you could go to the table data and then just subtract the accumulative precipitation from day X minus day X minus 1. And then you can get the data that way. All right. Well, that is it for this exercise. What we did was we went up to our unsteady flow data, meteorological data, and then added in gridded precipitation data in a DSS format by downloading that data from the internet, formatting it by using the importer tool, and then ultimately using this unsteady flow data, loading it into RAS Mapper, and then it's ready to go for our HEC RAS simulation.